Hello, welcome back to Cracking the Cryptic, where one of our viewers has suggested that we take a look at this puzzle. It's from the website dailykillersudoku.com, and it's called a greater than Sudoku puzzle. Now, I haven't seen one of these before, so I had to look up the rules, and you can see that there's a lot of similarities with a normal killer, except that some of the boxes or the cages here don't contain any number. And what's more, there are these greater than signs in the grid, and there's an equal sign here. And what this apparently means is that, so for example, if we look at this greater than sign, it means that the total of this cage is greater than the total of this cage. So it's not referring to the cell that connects the greater than sign, it's the whole cage that's connected that's got to be greater. So the challenge is to take a look at one of these and see if we can figure out how to do it. So that's what I'm going to do now. Right. Now. Okay, so I can see immediately. Oh, hang on, I'm getting a text. Okay, so I can see that we can start here. Look, we've got. We know that the total of any 3x3 block in a killer Sudoku will be 45 because it will contain the numbers from 1 to 9. And if you add the numbers from 1 to 9, you get 45. So here we've got complete cages totaling 25 plus 13 is 38 plus 6 is 44. So this cell here has to be a 1. Let's write that in. Okay, so this 6 now, I don't quite know how to do. How do you do pencil marks on this site? Okay, it just seems to be you just type the number in. There you go. So this 6 cage now has to be 2424 in some combination, which means this 13 cage is restricted. No, okay, well hang on a minute. So this 12 cage we know is greater than this cage, whatever this sum is, and that's greater than the sum of this cage, which is a 10 cage. So this cage here has to sum to 11. And we can use that because if this sums to 11, this funny shape here, this N shape, sums to 25. So 25 plus 11 is 36. So this cell and this cell, by the 45 rule, have to sum to 9. And we can't use a 1, 2, and 4 in those options. So this has to be 3, 6 in some order, and this can't be a 6 because it's part of a 12 cage in 2. So if this is a 6, this would also be a 6. So we'll make it like come as a 3. Yeah, it look like that. Okay. So this is a. I have to do it that way around. Therefore, this is a 3 and this is a 9. Right. Now this 14 cage now has to be 5 and 9. Let's put that in. And what are we left with? 7 and so this is 7, 8, this is 7, 8, but you can see this can't be an 8. We know this cage sums to 11. So if this is an 8, this will be a 3, and we already have a 3 in the block. So this has to be a 7, that's going to be a 4, and this is going to be an 8, like that. Okay, so what can we do now? Maybe we can use these greater than signs a bit more. Where have we got? Okay, yes we can. Yes, got an equal sign here. So you can see this 15 cage is less than the sum of this 3 cage here, and that's equal to the sum of this cage here. So, but this is a 26 cage. So we know this can't be too big. If this was the only options, because this eventually equals a cage of size 2 and it's bigger than the number 15, this is either going to be a 16 or a 17. Now, if this is a 17 plus 26 is equal to 43, so both of these cells would have to equal 1 in order to make the total 3x3 block add to 45. So this actually must be a 16 cage, and we have a 9 here. So this is an this is a 9, this is a 7. This sums to 16 somehow, which means these two cells have to add to 3, so they have to be 1, 2 double like that. 9, 9. Okay. Now we know these three cells sum to 16. So one option would be that they contain a 9. I guess if they contain a 9, then the only way that would work is with a 9 and a 3 and a 4, because we already have a 1 and a 2 in this 3x3 block already. So this would have to be 3, 4, 9. But you can see that's not possible, because let me show you what I mean here. We have a 9 double here, and we'd have a 9 in one of these three cells. So we've sort of got an X-wing on 9s here, in the sense that, you know, if this is a 9, this is going to be a 9, and if the 9's in either of these positions, this would be a 9. So there's definitely no more 9's in columns 2 or 3. So the 9 is going to be forced over here in this block. Now once the 9 is in one of these three positions, this 15 cage has to be a 7-8 combination. So it would have to be like that, but that's impossible now, because now we need to place an 8 in one of these two cells that we've just said are going to be some combination of 3, 4 and 9. So we know that there is no 9 in this block. Therefore the 9 has to be down here somewhere. But we have to make sure that this can add up to the right number now, this 16 cage. So what are the options for that? I'm not sure. I think there are still quite a few options for that. We know there's a 9 here, so we know that the 9 over here is going to be up here somewhere. So I think we're going to have to think harder in order to resolve where that 9 can go. Right, so what now? Where can... This 1 is interesting in the sense that it interacts very heavily on this cage here. You can see that the 1 is it's obviously either in this 31 cage or it's not. Now if the 1 is in the 31 cage, this 31 cage becomes extremely restricted, because the other numbers would have to add to 30 in 4 cells, so they'd have to be 6, 7, 8 and 9. And if the 1 is not in the 31 cage, it could only be here, which also has a lot of implications, because if we look at this 3x3 block now, we know that it's got to sum to 45 altogether, where we've got 31, we've got 3, so I know these 3 cells have to sum to 11. So if this is a 1 here, these two cells would have to sum to 10. And that would be quite restricted. It's almost worth just checking this. If this is a 1, this has to be a 1, because we need to put a 1 in one of these 3 cells, and it obviously can't go in the 11 cage. That would resolve, that would mean this would be a 1 here, therefore this would have to be a 1. Now where can we place a 1 in this middle block? Can't go here because it's a part of an 11 cage. Can't go... So the only other... If it doesn't go in the 21 cage in this position, it would have to go here. Well, that's impossible, because if the 1 went here, these two cells would have to sum to 16, which means that they would have to be 7 and 9, and this can be neither. It can't be a 7 or a 9, because we already have a 7 and a 9 in column 4. So this would have to be the 1. And once this is a 1, what else can we prove? This can't be a 1 for the same reasons this can't. This would have to be a... This is going to be a 1. So we're getting quite forced at the moment. How can we fill this 21 cage now, given we can't use a 9? And we know these 3 cells have to sum to 20, so that's got to be 8, 7 and 5 in some order. Let's just put that in. 5, 7, 8. 5, 7, 8. So now 6. This cell. So this cell cannot the maximum value of this cell is a 4. This is going to be a 2, 3 or a 4. I'm now looking at the relationship. You can see that there's a greater than signs between this cage, and this cage. But these two cells are very restricted now. They have to sum to 10. And this has got to be 2, 4, 2, 4 in this scenario. These have to sum to 10, so they're either going to be 4 and 6 or 2 and 8. So, but that's means this has to be 6 or 8, this has to be 2 or 4. So this just doesn't work. In fact, we've now proved this doesn't work, because let's look at the maximum value now of this cage. The maximum value of this cage is if this is a 3 and this is a 4. So this cage could, as a maximum, add to 7. If this adds to 7, it's greater than this cage, so the maximum value of this cage would be 6. But that's got to be greater than a cage containing 3 cells. Well, the minimum number that a cage containing 3 cells can sum to is 6. So this, in fact, this whole trial and error using this 1 here has proved to be incorrect. So I wonder if it'll let it. Oh, great, it does. So I can now undo all of that. This is not a 1. So these 3 cells have to sum to 11 without using a 1 and without using a 3. So they've got to be 2, 4 and 5. 2, 4, 5, 2, 5, 2, 4, 5. Now this 6 cage now can't be 2 and 4, because otherwise both of these cells would then have to equal 5. That's not possible. So this has to be 1, 5, 1, 5. This gives us a 5 here, which is nice. Now, what can we do next? Oh, hang on, we can use a beautiful bit of logic here. Now, we know the 9 in this 3 by 3 block is going to be in one of these cells. Not technically, I suppose, one of these 3 cells. Definitely in columns 8 and 9 though. And we know, because this 13 cage can't be a 4, 9, because we already have a 4 here. So the 9 over here is in one of these 4 cells. So we're able, again, we've locked 9s in this 3 by 3 cage, also into columns 8 and 9. So however these 9s arrange themselves, it's going to be impossible for there to be any 9s in these 6 cells down here. But we did a load of work earlier on proving that the 9 in this 3 by 3 block was in the top, it was in row 7. So it's in one of these 3 cells, but we now know it can't be in either of these cells, so it's got to be here. But that really restricts the value of this cell, because we know this can't be a 1. The minimum value of this is a 2. So this has to be greater than 11. So this can only be, we have a 9 here, this can only be a 7 or an 8. And this has to be a 2 now, I think, because it can't be bigger than that. If it can't be a 3. If it was a 4, this can't be big enough. So this is a 2, which means this must resolve itself this way round. 4, 11. Right, and this central block is getting very restricted now as well. We've got 21 cage, plus 9 is 30. So if this was an 8, these 3 cells would have to sum up to 7 in order to make the total for the whole 3 by 3 block equal 45. Now, is it possible for these 3 cells to sum to 7? Well, this would have to be a 1. This would have to be, well, this just isn't going to work. If these 3 cells have to sum to 7, this has to be a 1, this has to be a 2 or a 4. Now, if this is a 2 or a 4, this is a 7 or a 9, which is ruled out. So these cannot sum to 7, which means this cannot be an 8. This has to be a 7. So this is now 16 plus 21 is 37. These three cells are summing to 8. Now, if this was a 5, this would have to be a 2. Now again, so this cannot be a 5, so this must be a 1. So it has to be this way round. Oops. So this has got to be, how's this going to work now? This can't contain 5, this has to be 3 and 4 in some order. So this has to be a 4, this has to be a 3, and this has to be an 8, which is very handy indeed. So this 17 cage now, these two cells have to sum up to 13. You can see this cell here, therefore, has to be a 4, 5, or a 6. Can't be a 4, has to be a 5 or a 6. Which means this has got to be a 7 or an 8. Can't be a 7, so we can rule that out. So this has to be 5. Wow, what a beautiful puzzle so far. I'm very impressed with this. You can see simple Sudoku rules. We have 2 3s here, therefore we've got to put a 3 in one of these two cells. It can't go here, otherwise the 15 cage couldn't be filled. Place the 3 here, therefore. And this 8 means this is forced now to be 6 and 9 in some order. So let's write that in. Resolves this. 5, 5. We've got a 5 in one of these two cells here now. So in fact, this 26 cage now, it definitely contains the numbers 5, 8, and 9. So 22. So it's some combination of 4, 5, 8, and 9. Let's write that in. In fact, we have a 5 here, so we can rule the 5 out there. And this has to be a 9. So this is all forced just from the logic we've just discovered. 5, 9, 1, 2. So this has got to be what, 3, 4, 6 is it? No, 3, 6, 7. Like that. This 13 cage now must be 6, 7. It's the only option, which means this is an 8, which means this is an 8 and this is a 4. There's a 4 in one of these two positions. Can't tell which way round yet. And this has got to add to 10 or less. I feel like we're nearly there now, but we'll just go a bit further to make sure. You can see that we need to place this 2, forces a 2 into one of these two positions, therefore this cell has to be a 2. So let's put that in. So it's a 2 here, 2, 2, 2. So now these two cells have to be 2 and 4 in some order. And we're left with, 1, 3, 6 into these 3 cells here. So this in fact has to be 6, 1, 3. Five, 7 down here. It's a bit irritating that the 6, 4 alternative isn't ruled out there. But you can see now these two cells here have to contain a 1 and a 3, and the other digit will be a 4 or a 6. So the 1 has to go here now. 3, 4, 6, 3, 4, 6, like that. And then we've got 2s here, 2, this has got to be a 2, I think. This must be a 5, oops, a 5. 5, 5, that must be a 5 up there. So this has got to be a 6 now, and this must be an 8. Which resolves this, 9 and 6. 9, 9, and this must be a 7. Oh, I've got that. I find this method of input quite counterintuitive, so I keep messing it up. Anyway, oh god, there we go. So we can remove the 6s from these two positions, and we're looking at 1, 9 here and here, so that must be this way round, and 6, 8 here and here, so that's going to be that way round. Like that. So I think we're there now. I think we've solved it. Very nice puzzle. Didn't have the feel to me, maybe I'm wrong about this, didn't have the feel of a computer generated puzzle. Felt very, very logically put together, very nicely put together. Really involved some quite careful deductions being made, and I thought it was excellent for that reason. 147 across there. So it looks, the final stage looks like we're going to have to use this greater than sign here to do something. So we can actually place 4 here though, and that's got to be a 2. This can only be a oops. This can only be a 3 now. Which allows us to remove a now that's got to be a 6, a 7 there. That's got to be a 1 therefore. This must be a 4, 7. 4, 7 into those two squares. You can see we've got to place 2 and 3 up here, so that's got to be that way round, I think. Which means this must be this way round, I think. 9, 9. That's got to be that way round. Okay, what are we left with now? So 1, 4, 7 up here, so this has to be, I think this square here has to be a 1. That's got to be a 6 or a 7. And what have we got left to place? We've got 4, 6 and 7. You see, this simply cannot be a 4, because if it is, this can't be greater than this. So this must be the 4 here. And this is going to be 6 or a 7. Okay, and you can see this beautifully. This big shape here is going to resolve because this contains a 4 or a 7. This cannot be a 7 here. That's going to have to be a 6. That's going to have to be, which means that's a 6. That's a 7. This is a 7, and that resolves this as well. Absolutely beautiful puzzle. I really do think this is excellent. Thank you for recommending it to us. I'm certainly going to do more of these if they're up to this sort of standard. Really lovely logic. If you enjoyed the solve, please do subscribe to the channel. We really appreciate it. And we'll see you again next time on Cracking the Cryptic.